Hi. In this session, we're going to talk about implied forward rates. First of all, let me specify that implied forward rates is not the same thing as forward rates. Forward rates you can purchase or sell through a contract, and that's not what this is. These implied forward rates are not rates that you will actually ever see or that you can lock in or do something with. They are merely that they are implied by current spot rates. A spot rate is any rate that starts at time zero, starts right now. So if I can get a 1 year interest rate today, okay, that would be a 1 year spot rate. If I can lock in an interest rate for the next year, I lend money to the bank for 1 year, 1 year certificate of deposit. That's a 1 year spot rate. Suppose I want to lend money to the bank for 2 years. Okay. That would be a 2 year spot rate. So a spot rate is anything we can get right now. A forward rate is a rate that starts at some point in time in the future and ends even further in the future. Now, you can lock those in, you can have contracts for that, but that's not what we're talking about here. We're talking about what is implied by the spot rates. Okay, so now that I've thoroughly confused you, let's take a look at the class notes and see if we can see what is our motivation for being interested in implied forward rates. Okay, so let's suppose you are a corporate treasurer and your job is to invest a large sum of money, and you need to invest it for 1 year. And your primary goal is to have the most money possible at the end of 1 year. And you're only going to invest it in treasuries because you believe that it has to be conservatively invested. And since the United States Treasury is the only instrument that's allowed legally to print more money, that is where you decide that you're going to invest the money. Okay, we're going to make it real simple, and we're just going to talk about $100. Okay, but it would apply if it was a million or 10 million or whatever the amount is. But so you got $100, and you want to have the most money possible at the end of 1 year. Now, again, to make things simple, you've got two choices, okay? One is that you can invest the money into a 1 year treasury bill, okay? So you invest the money today, you buy the 1 year treasury bill, and at the end of 1 year, okay, you have your money, okay? The yield on the 1 year treasury bill is 5.2%. The other option is you can invest your money into a 6-month treasury bill, which means you invest your $100 today, and at the end of 6 months, you've got some money. And then what you're going to need to do at the end of that 6 months, since we want money in a year, you're going to need to roll that money over into a new 6-month treasury bill 6 months from now. Now, the yield on a 6-month treasury bill is 5.0%. So two choices. You can put your money into a 6-month treasury bill and then in 6 months roll it over into another 6-month treasury bill, or you can put your money into a 1 year treasury bill. You have your money at the end of 1 year. The question is, which will you do? If your goal is to have the most, they both have there's no risk of default, okay, because this money is going with the United States Treasury. Which are you going to do to have the most amount of money at the end of 1 year? Now, there's not a right or wrong answer to this, okay, like do this one or do this one, but there is a right answer in terms of how to evaluate the decision. And that's what we're going to learn about here. So first of all, we got to realize that whenever we see quotes, okay, like yields or yield to maturities or bond equivalent yields, for us, they all mean the same thing, okay, that these are annual numbers and they are the semi-annual yield doubled, because all treasuries and all corporate bonds, at least all the ones that we're going to be dealing with, that have coupon payments are making their coupon payments semi-annually. So everything is done semi-annually. So you first of all have to realize that when you see a 6-month treasury bill with a yield of 5%, the semi-annual yield is going to be 2.5%, right? 5% divided by 2. And the 1 year treasury bill is going to have a yield of 2.6%. Okay, so that's the first step in there. Okay, so what do we want to do in this situation to be able to have the best amount of money? Well, let's take a look at a visual that will help us out a little bit to understand what we want to do and why we want to do this. So let me pull up an illustration that I have put together here. Okay. And here we start out with $100 at time zero. Okay. And we are first of all going to define something we call the zero rates, the Z's. Okay. Anything that is a Z for us means it starts at time zero. It also means that it is a zero coupon bond. There are no coupon payments in between. So Z1 is the interest rate you can get going from time zero to time one. Now, time one is after 6 months because these are 6-month increments here, okay? Because there's semi-annual compounding on all of our treasuries. So the rate for Z1 is 2.5%. If the 6-month treasury bill has a yield of 5%, that means the 6-month rate is 2.5% for that, okay? So this is pretty easy to be able to see there, okay? What happens is you invest $100 for one 6-month period at 2.5%, and you have $102.50 at the end of that period of time, okay? So that's what we get with the 6-month treasury bill. Now, we're gonna have to roll it over, but we'll get back to that in a second. Now, if you invest your money into a 1-year treasury into a 1-year treasury bond, okay, the yield on that was 5.2%. So the semi-annual yield was 2.6%. So what that means is you're going to get 2.6% for 2 semi-annual periods. You're going to get 2.6% for the first semi-annual period, and you're going to get 2.6% for the second semi-annual period. So we're going to say Z2 is 2.6%. You can get this zero rate, okay, going from time zero to time 2 of 2.6%, but it's 2 semi-annual periods, okay? This was Z1 going from 0 to time 1. You got 2.5% for 1 semi-annual period. Here you're getting 2.6% for 2 semi-annual periods. So how does that work? Well, let's go to the whiteboard and we can draw this up fairly easily here. We're going to be able to say, as you know, that the future value is equal to the present value times 1 plus R to the T. Well, for our 6-month treasury, there's only 1 semi-annual period. So our future value was equal to 100 times R was 2.5%, our semi-annual yield, 1.025 to the first power, right? And so that was going to be equal to $102.50. Okay, so that's what you have at time 1, at time 6 months. For our 1-year treasury, okay, same formula, future value is present value times 1 plus R to the T. We've got our future value is going to be 100. Now it's 2 semi-annual periods, and it is going to be at 2.6% is the semi-annual yield on that. 5.2% annually is 2.6% semi-annually. So it's going to be multiplied by 1.026 squared, because you're getting 2.6% going from time 0 to time 1 and 2.6% going from 1 to time 2, because it's a 1-year treasury. So this one you probably can't do in your head, okay? 100 times 1.026 squared, that's $105.27. And you can check that out in Excel if you want to. And it may be rounded, okay? But $105.27 is what you're going to have. So that's how much money you have at the end of 1 year. If you go with the 1-year treasury, you have this amount. This is the amount of money you're going to have at the end of 6 months if you go with the 6-month treasury. Okay, so let's go back to our diagram here. and see what we have there. Okay, so as you can see here, there we have the $102.50 at the end of the first 6-month period. And if we buy the 1-year treasury, we end up with $105.27 right there, as we just saw. So the question was, do you want to have this $105.27 by going with the 1-year treasury, or do you want to go with the 6-month treasury and then roll it over and then have some unknown amount at time 2? Well, let's suppose you are standing here at time 0 and you think interest rates are going to go up to 50% 6 months from now. Well, if you think interest rates are going to go up to 50%, then golly, let's take this $102.50 that you're going to have at time 1, and now you can reinvest it here at what you think is going to be 50%, and you will have a lot more than $105.27. Clearly, that's the direction you should go. So if you think interest rates are going to be really high from time 1 to time 2, you want to put your money in the 6-month treasury bill and then roll it over into another 6-month treasury bill when you think interest rates are going to be really high. But let's suppose you think interest rates are going down to 0, okay, in 6 months. So you're standing here at time 0, and you always know what are the rates that start at time 0, because you can always look on the internet or read. I used to say read in the newspaper. We don't have newspapers too much anymore, but you always look up what are the rates right now. You can get quotes on the rates right now. Okay, so you always know these Z rates. So you know you can get 2.5% for 6 months, or you can get 2.6% for 1 year. What you don't know is what is the interest rate you can get from time 1 to time 2, because that's in the future, okay? So you don't know what rate you can get on that. However, let's suppose you're standing here at time 0 and you think the interest rates out here are going to be 0. You think interest rates are going to drop to 0 in 6 months for whatever reason, okay? I think there's going to be a recession, the Fed's going to lower interest rates, or whatever you think is going to happen. Well, now, if that's what you think, if you go into the 6-month treasury bill, and you roll it over at 0, that $102.50, it's still going to be $102.50. And that's not the way to go. You're much better off going with the 1-year treasury bill, where you're going to have $105.27. So what we see here is, if you think interest rates from time 1 to time 2 are going to be really high, then you want to go with the 6-month treasury bill and roll it over at those really high rates. But if you think interest rates are going to be really low from time 1 to time 2, then you want to go in 1-year treasury, so that you're locking in this 2.6% for 2 semi-annual periods. So what you choose to do is going to be determined, okay, the right choice is going to be determined by what you think interest rates are going to be from time 1 to time 2. Now, so what we're going to do is we're going to call this rate from time 1 to time 2 1F2. 1 because it starts at time 1, F for the word forward, and 2 because it ends at time 2. What we want to find is we want to find the implied forward rate. The implied forward rate is the rate that, if it does come from time 1 to time 2, would make you indifferent between going from 0 to 2 versus going 0 to 1 and then 1 to 2. In other words, there's some interest rate that, if it comes from time 1 to time 2, would give you $105.27 either way, which means you don't care. So you're going to have $105.27 if you start at $100, take the 1-year treasury, and it becomes $105.27. However, if you take the 6-month treasury, okay, and it ends up being $102.50 here at time 1, there is some interest rate that will cause the $102.50 to be invested for 6 months and become exactly $105.27, okay? And that is the implied forward rate. The implied forward rate is the rate that, if it takes place out here in the future, will give you the same amount of money, in this case at time 2, whether you go from 0 to 2 with the 1-year treasury, okay, with Z2, or whether you go from 0 to 1 with the 6-month treasury, that's Z1, and then roll it over from time 1 to time 2, okay, with the 6-month treasury at that point in time, which would be 1F2, the implied forward 6-month rate 6 months from now. Let me say that again. 1F2 is the implied forward 6-month rate, because that's a 6-month rate going from 1 to 2, 6 months from now, because we're standing here at time 0. 6 months from now means we start at 1. So starting at 1, going to time 2 is the implied forward 6-month rate 6 months from now. So how do we find that? Well, we know the idea is the 1F2 is going to be the rate that gives us the same amount of money at time 2, whichever path we take, going from 0 to 2 with Z2, or going 0 to 1 with Z1, and then 1 to 2 with 1F2. So we set them equal to each other, okay? So going from 0 to 2 is getting Z2 twice. So again, 1 plus Z2, okay, times 1 plus Z2, okay? Just like what we, Z2 for us was 5.2%. So this is 1 plus 5.2% times 1 plus 5.2%. That has to be equal to 1 plus Z1 times 1 plus 1F2. In other words, we want it to be equal going this path as we, the same amount of money as we go with this path and then this path. And that's what this is saying right here, okay? Now, of course, 1 plus Z2 times 1 plus Z2 is 1 plus Z2 squared, isn't it, okay? So we want 1 plus Z2 squared to be equal to 1 plus Z1 times 1 plus 1F2. We want the same amount of money, whether we go with this big step from 0 to 2, that's this right here, or whether we go with 2 small steps, 0 to 1, and then 1 to 2. That's what we've got over there. Now, we know what Z2 is, okay? We said that Z2 is going to be 2.6% as a semi-annual yield. And we know what Z1 is. Z1 is 2.5% as a semi-annual yield. So if I know Z2 and I know Z1, I've got one equation with one unknown, and I can solve for 1F2. So let's go back to the class notes and be able to see how we are actually doing that, okay? So we're going there and we're saying basically here that, here we go, that 1 plus 1F2, well, here's what we looked at before here, okay? So that's 1 plus Z2 squared equals 1 plus Z1 times 1 plus 1F2. Solve for 1F2. So I put 1 plus 1F2 over here on the left-hand side, okay? And so we divide each side by 1.025, and we've got this. So we end up getting that 1F2 is, and it's important to take this all the way out to the end, okay? It's important to take it all the way out to the end. 1F2 is going to be 0.27001. You don't want to leave off that 001, and I'll tell you why in a minute. But you don't want to leave off that 001. You end up with 2.7001%, and that is going to be 1F2. If you express it as an annual number, that means you double it as a bond equivalent yield, that's going to be 5.4002%. So that is going from time 1 to time 2. Now, let's take a look at things here and see if we can see a way we can kind of understand this a little bit better. I want you to notice that as we look at semi-annual yields, okay, going from 0 to 1 is 2.6%. Going from going from 0 to 2 is 2.6%. Okay, going from 0 to 1 is 2.5%, and we want to find what is it going from 1 to 2. Let's look again back at our diagram. I think that'll help us be able to see this. So when we're trying to find 1F2 here, we know that it's 2.5% here, and we know it's 2.6% doing that. Think of it this way. Think of going from 0 to 2 as being an average of going from 0 to 1 and 1 to 2, okay? So 2.6% is an average of 2.5% and what? Okay, 2.6% is an average of 2.5% and 1F2. What must 1F2 be So that 2.6% is an average of 2.5% and 1F2. Well, that one you can do in your head. 2.7%, right? 2.5%, 2.7%. What's the average of that? 2.6%. That tells us 1F2 is going to be 2.7% and close to it, okay? Because while 2.6% is an average of Z1 and 1F2, okay, it's not an arithmetic average. It's a geometric average. So the real question is 2.6% is the geometric mean of 2.5% and what? And there the answer is not 2.7%, but the answer is 2.7001%. So let's go back to our notes, okay? But this kind of helps us to be able to see what it is we're doing here, okay? That 1F2 is going to be pretty close to 2.7%. It's going to be 2.7001%. But it's important that you don't say 2.7% because as we get further out, we'll find that the geometric mean and the arithmetic mean will be reasonably different from each other. They'll be a little more significantly different from each other, okay? So here we have been able to find the what is the implied forward rate. So the implied forward 6-month rate 6 months from now is 2.7001%. If we want to express it as a bond equivalent yield, as an annual number, we simply double that to 5.4002%. Okay, so we've kind of got the idea right now about doing implied forward rates and how we're going to be able to solve that. We're going to continue on with this in the next video and be able to take a look at how do we get some that are a little bit more complex. How do we get 2F3, 2F4, 4F5, and some things like that. But make sure, first of all, you understand how we were able to get 1F2 and what an implied forward rate is.